All right, cool. All right, so my name's William. I work at Open Robotics. For a while now, I've been working on the launch system for ROS2, and I'm going to jump right into it because I only have 10 minutes. So, obviously, when migrating something from ROS1 to ROS2, we want to take the opportunity to think about how we could do it better, what we can improve on using our previous experience. Here's just a couple of the things here, things like improving the ability to introspect the launch files, both for like editing tools and also just when you have a really big, complex launch file for like understanding it easier. We wanted to have more reactionary behavior capabilities in launch. I know if you're familiar with the ROS launch from ROS1, you'll know about respawn and required, which will, do something when the program, when you put those settings on it, when those programs close. There's always been people talking about verification. When I describe a launch file and I say run, how do I know it actually ran that thing? And also people have lamented over the limitations of the markup language, XML-based files, and they always ask for Python API, and I'm not 100% convinced that's the best thing for everyone to do all the time, but we want to have a first-class version from the get-go. There's a lot more stuff that I can't cover here, but there's a pull request for the design doc, which if you're interested in where launch is going, I'd recommend getting up to speed on that thing. Also, there's some things we have to change about launch in ROS2 because of the way that ROS2 works. So in a lot of things in ROS launch and ROS1 assume a single node per process, which is no longer the case in ROS2. And so we have to make some changes according to that. We essentially need to know, or ROS launch needs to know the mapping between nodes and processes. I think as also mentioned before, parameters are a bit different in ROS2. We no longer have the notion of a global parameter space. We can still have a node that you can call the global parameter server that anybody can read and write to, but we don't have a master that holds the parameters or anything like that. So those are things we have to change. So I'm going to jump directly into some examples, but a disclaimer, these examples are using the latest and greatest syntax, which may not be available in Bouncy or even on master yet, but we're working on it. I thought it was better to show what's going to be as opposed to what is. Interesting. There's an example here. This is the simplest example I could come up with. This is simply runs a talker and a listener. And you can see that it's a Python interface. There's this convention that if you have a file that ends in .launch.py, that's not a strict requirement, that's just a convention. But if you also have in that file a function called generate launch description, you can just do things like ROS2 launch package name file name. And so this is equivalent to what you would do if you had an XML file in the past. You can also introspect it by doing -- print description. But this is the absolute simplest version of a launch file. Hello. Okay, and so what's actually going to happen here should be pretty obvious if you're familiar with launch. It's going to go out and find the executable for these two things and run them when you ask it to run. We'll iterate on this slightly, and we'll say we want to change the names of the nodes that we're running. So in this case, we're still finding the talker and listener, but we're adding a node description. And this is a bit about what I was talking about by needing to provide launch the understanding between processes and nodes. So here we're saying we're running two processes, and in each of them there is a node, and I want to change the name of it. So I'm going to change the name to my talker and my listener, and what that ends up doing is it runs those programs again, but this time it passes arguments to them to affect the node name for the nodes within them. So then you might ask yourself, what happens when you have more than one node in a process? So here's an example of a node or an executable that has more than one node in it. This particular example that I picked actually has 4 nodes in it, but in this case we'll just want to, it also has a talker and a listener in it, but in this case we'll just want to change the name of the talker and the listener. And so here we're going to run an executable, and then we're going to tell it that there is a talker node that we want to change the name of and a listener node that we want to change the name of. And what that ends up doing on the command line is calling the executable and then passing a very similar thing here, but it needs to tell the executable which node it's talking about when it's passing these remapping arguments. So we say, for the listener, this argument applies. So that's an example of like a fundamental relationship between ROS launch and the things it's running that has changed in ROS 2. We have this new thing as well. It's not really new, but it's a new way of doing basically the equivalent of nodelets. But instead, you just create nodes, and we can load them dynamically without any extra work. So what happens here is we're running this boilerplate container process, and then we're telling launch that we want to run in that process, we want to run a talker and a listener and change some of the settings of it. And what's going to happen is that this executable is going to run, and then based on information given to it, it's going to go out to the system and find where these nodes are, usually in shared libraries, and it's going to instantiate both of them in itself. And then they're going to share threads and other kinds of resources and stuff and communicate with each other more efficiently. Another thing that's been touched on in one of the previous talks as well is this idea of a lifecycle talker and listener. And I want to use this to illustrate the more event-driven nature of launch in this new reference implementation that I've been working on. So we're going to start out by defining a lifecycle node. We do need to tell launch when a node is a lifecycle node and when it isn't, so that it knows whether or not to expect to be able to introspect its state and stuff like that. And then we're going to say we're going to run an executable that contains that node we described. And then where it gets interesting, and I know there's a lot of text on the screen here, but I'm going to highlight some things and walk through it. We can tell launch that we want to do something when there's a state transition that affects that talker node that we described before, and specifically when it moves into the active state. And so when that happens, we want to do two things. We want to log an info message, and we want to execute another process. So in this case, we're going to run talker, and then we're going to wait for talker to get to a certain configuration state, and then we're going to run the listener, which hitherto has been pretty difficult to do in launch. So that's pretty exciting. I feel like there is a slide missing. Interesting. Okay. But there's a whole bunch of things I didn't have time to cover. There's all the things you like about ROS launch from ROS 1. There's substitutions, there's arguments. You can include other launch descriptions. You can have conditions for whether or not processes or groups of processes are executed. There's a whole bunch of new stuff with introspection. Again, I have some links at the end if you want to look at those to get up to speed on those. There's some things that are a lot of things are missing. We still don't have a markup language representation. Right now, you can only write launch descriptions as Python files. I still personally believe it's really important to have a static markup language option. And I even would go so far as to say it might be the default thing people should use in the future. But we can hopefully, if I've done my job right, build those on top of the existing Python API quite easily. Like translating from these markup elements to the Python code should be pretty linear. Given a lot of thought to verification, but there's a lot of tools that are missing there. Some of you may be familiar with ROS tests, and we're missing an equivalent to that. There's been some work done on it already, but it's still evolving. And another big one that's missing is multi-machine launch. So if you're interested in this topic, we could use some help trying to fill out these gaps. And here's some pointers and then questions, and I almost ran out of time.
Well, what would it take to run ROS 1 nodes using the new ROS 2 launch bring up? Is that something that's tractable at all?
Yeah, it's totally possible. In fact, something that ROS launch from ROS 1 didn't do very well, or made it unnecessarily convoluted, was that in launch, there's actually, launch is split into two pieces. There's a package called launch, which has no dependency on any ROS thing, and you can just run processes. And then there's launch ROS, which has all the ROS specific stuff. It would be very easy to create a ROS 1 extension to that in the same way we have the ROS 2 extension to that, that looks up. Really the only difference in ROS 1 and ROS 2 is how it translates arguments to launch into command line arguments and how to locate the executables, and that's easily done in Python. And so yeah, I think it would be really easy to use this in ROS 1. And even the core piece doesn't have any dependency on ROS 2 stuff, really. Just a Python package.
Thanks.
Thank you very much.
Okay.